There are moments in human history when the truth hides itself beneath the dust of centuries, waiting for the right hands to uncover it. Imagine diving into the crystal waters of the Aegean Sea, sunlight breaking into shards above, and seeing a strange, ancient shape resting in eternal slumber. Covered in corroded bronze and thick marine incrustations, it appears at first glance as nothing more than an artifact of a forgotten age. Yet within this sleeping relic lies the beating heart of a machine that whispers secrets across 2,000 years. Known to us today as the Antikythera mechanism, it is believed to be the world's first analog computer, capable of predicting the dance of the heavens. But what if this device was not only a map of the stars? What if its gears carried the same principles that allowed the ancient Egyptians to lift the very stones of the pyramids? The year was 1901. Off the coast of the Greek island of Antikythera, a group of sponge divers sought fortune beneath the waves. Storms drove them deeper than planned, and it was there, in the dark stillness, that they found a wreck from the ancient world. Amphorae lay scattered across the seabed. Statues of bronze and marble stood half buried in sand. But among them was something stranger still, a lump of metal split into pieces, fragile as if made of clay. It took years and the invention of advanced imaging for its true nature to be revealed. Inside the fragments were rows of intricately cut bronze gears, perfectly meshed, turning with a precision that rivaled the finest clockwork. Scholars were stunned. The technology they believed should not have existed in 100 BCE. The Antikythera mechanism was a marvel of engineering. 30 or more gears, each with carefully measured teeth, were housed within a wooden case, now long rotted away. By turning a hand crank, the operator could display the positions of the sun and moon, track the cycles of eclipses, and even predict the movements of planets visible to the ancients. Its sophistication begged an unsettling question. If such mechanical genius existed in ancient Greece, could earlier civilizations, like Egypt, have harnessed similar engineering principles in other ways? Might a gear-based calculator have determined the lifting angles of massive stones, or calculated the counterweight ratios needed to construct a pyramid? The Great Pyramid of Giza rises like a mountain carved by human hands, an eternal witness to ambition and skill. The blocks that form its bulk weigh between 2 and 80 tons each, placed so precisely that even a modern credit card could barely slide between them. Mainstream theories speak of ramps, sledges, and thousands of laborers, but others envision something more refined, a complex pulley and counterweight system, guided by precise measurements. Imagine a team of engineers with a device, gears turning, needles pointing, calculating exactly how much force would lift each stone, how to adjust the rope angles, when to apply pressure, when to release. In such a vision, the Antikythera mechanism's ancestors might not have been astronomical calculators at all, but construction instruments of breathtaking precision. History is a tapestry woven with both light and shadow. For every triumph recorded, countless achievements vanish into the void. The burning of libraries, the fall of empires, and the forgetting of trades have erased knowledge beyond imagination. Perhaps the Antikythera mechanism is not the beginning of a story, but its final chapter. A survivor of a lineage of machines whose functions ranged from celestial tracking to monumental construction. If so, then what we hold in museums today is but a faint echo of humanity's true past. There exists a theory, unsupported by hard evidence, yet endlessly intriguing, that the knowledge embedded in the Antikythera mechanism and the Egyptian pyramid designs came from elsewhere. From the stars, perhaps? The alignment of the pyramids with Orion's belt, the astronomical precision of ancient temples, these facts stir the imagination. Could visitors from beyond have gifted early humans with seeds of technology? Or is this a testament to the incredible, often underestimated genius of our ancestors? The answer may never be known, but the question lingers like starlight on the horizon. Measurements taken with modern equipment reveal astonishing accuracy. The base of the Great Pyramid deviates by less than a fraction of a degree from true north. The stones are aligned with an exactness that defies simple tools. To achieve such precision, one must measure, calculate, and correct with care. If an ancient, gear-based calculator existed, whether in Egypt or a precursor culture, it could have been the silent partner in this monumental work, guiding every stone to its perfect resting place. The Antikythera mechanism is not just an object, it is a question, a riddle whispered across the centuries. Whether it tracked the stars or aided in the raising of megaliths, its existence changes the way we see the past. Perhaps there are more such machines, lying beneath the sands or the seas, waiting for curious hands to find them. Until then, the gears of history turn unseen, and the mysteries of the ancients remain silent, patient, and eternal.